So last time I did the chapter 3, the biological molecules, and it's mostly for the MCQ. And last time I also forgot to remind you that it's good if you know how to draw the glucose structure, the hexose. And there's some difference between the glucose and galactose. I hope you know that. And also the alpha glucose and beta glucose, there's some different structures. The structures stay the same. I mean, it's just for carbon 1 and carbon 3, and also carbon 4, the H and OH will be upside down for glucose and galactose. Try to look at that. It's good to know if you know how to draw the structure. And for protein, I also recommend that you know how to draw it. It's like, two amino acids connected to each other, and there will be a peptide bond between carboxyl group and amino group of another amino acid. So it's good to know that. And then what else? What else did I forget? Does anyone know what is the difference between saturated fatty acid and unsaturated fatty acid?
Unsaturated fatty acid has like double bond, right? But unsaturated is single bond.
Yes, it has something to do with the single bond and double bond, but the information is a little bit wrong. Saturated fatty acid will have single bond, and unsaturated fatty acid will have double bond, right? Let me double check it. Last time we were asked about that, and then what about the physical state? The physical state of the saturated and unsaturated fatty acid? Anyone? Anyone? No? Okay, let me share.
Is unsaturated fatty acids the one in liquid state?
Yes, that's correct. And then?
And then saturated fatty acids in solid?
Yes, that is true. So saturated fatty acid is literally fat because it's in a solid state, and unsaturated fatty acid is liquid, so it's more like oil. And for the melting point, I think you should know that too. Saturated fatty acid will have a high melting point, and unsaturated fatty acid will have a lower melting point. So let me write it down for you. Right, so can you see the screen here?
Yes.
So here, it's from Google, I just tag it. So saturated fatty acid, it have a single bond only here, and unsaturated fatty acid, it has a double bond. So the difference between saturated fatty acid and unsaturated fatty acid is that saturated, it have a single bond, unsaturated double bond, and then saturated is solid and unsaturated is liquid. And saturated will have a high melting point, and unsaturated fatty acid will have a low melting point. So that is what you need to know. Oh, and another one is in the biological molecule chapter. For the first lecture, there's a fraction of water. Can you turn on the lecture notes? I think it's on the page. I'm not going to share it on the screen because I'm afraid that my laptop will walk slowly if I share it. Can you see that on the first lecture file? And at the last page, there's a fraction of water. Can anyone see it? Do you get what I'm saying? Let me look for the lecture notes. Biological molecules. It is on page 103. It's on page 103. It's about water. The fraction of water is it's not fraction actually, it's significant features of water, high polarity, universal solvent, and so on. You have to know that too. It's for MCQ. All right, so if anyone got it, I would just move to another part of chapter 3. And today we are going to talk about the enzyme and some sort of, effects of the pH temperature on the enzyme. So what do you understand about the enzyme? What is the definition and what is the properties? Can anyone tell me?
Please.
Right, one by one, maybe.
What enzyme? What?
Yeah, the definition of enzyme, what is it?
Enzyme is a biological catalyst that speeds up chemical reactions in living organisms.
Yes. Yeah, that's true. And what are the features, like how does it work? Okay, more specifically, like how is it related to the activation energy?
It lowers the activation energy.
Yes, right? Lowers the activation energy. But there is some how can I say, argument about that definition. Lowers the activation energy and offers the alternative pathway with lower activation energy. What are the difference? Do you know that? If you have studied about enzyme in chemistry, your chemistry teacher will say that the enzyme doesn't lower the activation energy. If you give the definition that enzyme lowers the activation energy, then that is wrong. The enzyme doesn't really lower the activation energy. It only offers the pathway with lower activation energy. Is it clear? But I know that in the cell biology lecture, I can see that the enzyme lowers the activation energy. It's written like that. But let's just stick to this one because both chemistry teachers, chemistry 1 and chemistry 2, and even Dr. Wong, if you ask her, she will say that, offers the alternative path with lower activation energy is a more correct definition. Is it clear? Maybe I can draw it up for you. It means like, it's really hard for me to keep talking because I can see your face. But then I would just consider that, you are really paying attention to me. So let's say that, we want to reach this goal. This is our goal. And we have two options here, part 1, and then we have another part 2. So this is part 1. Part 1 means this one. Part 1 and part 2. For this part 1, we are alone. We don't have any companion. So in order to reach these goals, and because we are going alone, it takes a little bit effort, and it also takes longer for us to reach these goals. But for part 2, we are going with the companion. We will go with the companion. So because we have a companion, it's easier for us to reach this goal, and we don't have to take that much of time to reach this goal. So here for part 2, it is the companion is the enzyme. We are going to the same goal, and actually the same goal means that it's the same activation energy. But then for part 2, it takes us shorter. It takes us like lower effort or lower energy to reach this goal. So what I want to say here is that activation energy is actually not lower if we use the enzyme. Enzyme just offers the pathways to reach the same goal. Does it make sense? Is everyone clear?
Yes.
Yes.
Okay. Good. Just you can ignore the example if you don't understand the example. Sometimes the example I give might confuse more. So just stick to this one. It just offers the alternative pathway with lower activation energy. So that is it. So if we talk about the enzyme, we have to know the definition of the enzyme. Just now, one of the girls said that is a biological catalyst that increases the rate of reaction, which is correct. But does enzyme increase the number of products? Does it increase the number of products?
No.
Yes.
Actually, the answer is no. The number of products doesn't change. It stays the same. It only increases the rate of reaction. All right. So enzyme doesn't have impact on the number of products. Please take note of that. All right. And then what else? And for the enzyme, it doesn't change, right? At the end of reaction, it stays the same. It is used in the reaction, but it stays the same. So you need for enzyme, first of all, you need to know the definition, and its property is that the activation energy is not lower. It only offers the alternative pathway with lower activation energy. It remains unchanged at the end of the reaction, and then it doesn't affect the number of products, but it increases the rate of reaction. That is what you need to know about the enzyme. There might be definition for the enzyme. Right, and then what about the definition of activation energy? What about it? What is the activation energy? Anyone?
The minimum amount of energy needed to break the bonds.
Yes, it's the minimum amount of activation energy, right? I will share another screen with you. I will share the lecture notes with you. So you also need to know the definition of activation energy. There might be questions about that. So let me see here. The activation energy is this one. And also you must know the graph. You must know how to draw the graph, the labeling, you need to know it. Free energy, this side is free energy. And this is energy or product, energy or reactant. This one is the activation energy, AE. This one is AE. So the reactants, for the reactants to become products, it must have enough energy to overcome this AE. And this is called the activation energy. This is the definition that you need to know. You can write it in your own way as long as is the minimum energy. You can also say energy barrier. You can say anything. You can say it in your own word, but it must be correct. Okay, so here it says that it lowers the activation energy, but I don't recommend this definition. It just offers the alternative pathway with lower activation energy. So you need to know this graph as well. So here, this one is activation energy without the enzyme, and this one is the activation energy with the enzyme. There might be MCQ questions with graphs, and it will ask you about the which graph represents the activation energy with or without enzyme. It might ask you a question like this, so be familiar with the graph. So far, do you get it?
Yes.
Yes.
All right. Okay, so how does enzyme work? So the enzyme work in this way. First of all, this is the enzyme that we have, and then it will bind with the enzyme plus substrate, and we call this enzyme substrate complex. And then this enzyme substrate complex will undergoes transition state. Transition state. So what happened during the transition state? What happened is that reactants change. The enzyme doesn't change. Reactants change. The bonds in the reactants are either formed or broken. So bond formation is called the synthesis, and bond broken is called the degradation. So it will undergo transition state, and during the transition state, the bonds in the reactants will be either broken or the degraded. Or you can also say they are either formed or synthesized. And then later on, you will get the products, but at the end, the enzymes stay the same. It doesn't change. So this is a general process for the enzyme. This is how enzyme works. You can take note of it. You can use this concept to write the lock and key mechanism and the induced fit mechanism. Got it? Write it down here, and then you can read this one. This is the transition state. What happened in the transition state is that the bonds are broken or new ones are formed. The broken one is called the degradation, and the formation is called the synthesis. That is what you need to know. That is this. That is the general concept. And we can use this general concept to understand or write the structure question or the assay of the induced fit and the lock and key mechanism. So let's see. Okay, I want to ask you a question. So enzyme is made up of proteins, right? And protein have 4 different levels: primary, secondary, tertiary, and quaternary. So enzyme is what stage? Is it primary or secondary?
Secondary.
Secondary is considered what? Fi helix and BW dashi, right? Secondary. Anyone? Is secondary correct? I don't know how to pronounce the names though. Okay, the easier one for me to pronounce. Isaac. Is enzyme the secondary? No? Anyway.
Hold on. Yes.
Is it secondary? Really?
Is it primary? I have no clue.
What about Arizona? Arizona, is she here? Actually, enzyme is not secondary. Enzyme is tertiary. It's a globular protein and it has a 3D shade. Later on, if you read the letter notes, it will say about denaturation. And what happened during the denaturation is that the bonds in the enzymes are broken and it will lose its 3D shape. So 3D shape means is the tertiary. Here it also say that it is a globular protein. Enzyme is a globular protein, right? Please take note of this. Enzyme is actually a tertiary. For primary, it's just a covalent bond. It's just a straight line. So it's impossible for enzyme to be a primary. It is a tertiary. You can also check it and let me know if it is wrong. But it's tertiary. And then specific means that, we have the adicide here, right? The enzyme has an adicide. What is an adicide? You need to know the definition of that too.
The site where the substrate binds to the enzyme.
Yes, there's the site where the substrate will bind to the enzyme. Yes, there's the adicide. You can write it down like that. And reversible means like, if you understand the question here, the products can go to reactants. And usually, it's reactants where for the products, but if it is reversible, the products can also form the reactants. So it's reversible here. We use the reversible reaction. And then enzyme not destroy means like at the end of the reaction, when the products are formed, the shade of the enzyme remains unchanged, the bonds are not broken, is the reactants that are broken or that are formed. So enzyme doesn't change. And small quantity, you don't have to know that much, and it doesn't change the amount of products. And here it is affected by these three things: the pH, temperature, and the substrate and enzyme concentration. It's good to know these properties as well. Maybe the MCQ questions might ask you. So, if you already understand the concept of enzyme, it is okay. Just listen to me to get a revision, but try to listen to, what I say is important. And like I said, if you know what you need to study, it will be easier for you to do a revision before your final exam. And now I will go to Lock and Key mechanism and induced fit model. So just now I told you that so the enzyme works like this. Enzyme will first bind to the enzyme substrate complex. And then this enzyme substrate complex will undergo the transition state. And during the transition state, the reactants will change. The bonds will be broken or formed. And then at the end, you will get the products. So this goes for both Lock and Key mechanisms. So they are quite similar. So what is the difference between these two, Lock and Key and induced fit model? What is the difference? What's the difference?
Lock and Key mechanism shows that the enzyme doesn't change its shape when it binds to the substrate. But then the induced fit model says that when the substrate binds to the active site of an enzyme, the active site kind of like changes the shape to fit the substrate.
Yes, that is true. Great. So yeah, that's true. Lock and Key mechanism. Just now I told you to write this concept, right? This one. Let me show it again. This one. You can write this whole process for both Lock and Key and induced fit mechanism. But then, there's difference. So here, Lock and Key mechanism, we have an enzyme like this. We have an enzyme, and there's a site called the adicyte. This is called the adicyte. I'll just write it in short form. This is called the adicyte, and this adicyte, the shade of it is quite complementary to the substrate. So let's say that you want to bind substrate A. You want to bind the substrate A. So this will fit exactly into this side because this is only meant for substrate A. But let's say you want to fit substrate B, but this substrate, it has a different shade with the adicyte, so it cannot bind to this enzyme. So that's why, enzyme is called specific. Just now, the property of enzyme is quite specific. But for lock and key mechanism, the adicyte is already fixed, and it can only bind to the substrate that it wants. Any other substrate cannot bind to it. So the question now is, how will it come? Here, you can see the photo, right? The diagrams. In the question, what might come is like, it will not show you the label, but it will say like A and the B. And maybe the question will ask you, can B bind to the adicyte? Can B bind to it? Can it bind to the enzyme?
No.
No, right? So you already know that only A can bind to it. So the question will ask you like this. Sometimes, you might get it confused because the labels are not given. And it might even trick you by using a lot of substrates, a lot of substrate with different shades. So look at the diagram carefully and write it down. Write the correct answer. So anyway, yeah, this is substrate. And another thing that I would like you to know is when this enzyme, the adicyte of the enzyme and substrate are attached to each other, are connected to each other, is only a loose formation. The attachment is loose for the lock and key mechanism. But for induced fit mechanism, the attachment is quite strong. So just now you said that induced fit model, the adicyte doesn't really have a shape for the substrate. But as soon as the substrate binds to the enzyme, when this substrate binds to the enzyme changes its shape so that it can be fit firmly with the substrate. So the attachment is firm. It's a firm attachment between the substrate and enzyme. And then at the end of the reaction, the adicyte of the enzyme will change to its original shade and the products are formed. So that is it. Does anyone get it? Do you have any questions?
No.
Okay, then that's it. Okay, so far we talk about the enzyme, we talk about the activation energy, and then we talk about the adicyte, and we talk about lock and key mechanism, induced fit mechanism. So these 5 topics you need to know. Then you need to be able to write the definition of each and every topic. So take note of that and try to read it again. And now I will skip this. These are not necessary, but you can read it. Now let's move to temperature, pH, and substrate concentration. So does anyone already know what is the effect of temperature on the enzyme and what is the effect of temperature on the pH? Sorry, what is the effect of pH on the enzyme? Does anyone already know?
For temperature, is it 37?
Yes, that's
degrees
the optimal
Celsius?
temperature, right?
Oh, then like for pH, it depends on the enzymes, right?
pH, it depends on the enzyme. What does it mean?
Because some enzymes are produced in acidic conditions, like the stomach enzyme, pepsin, I think. Well,
Yeah,
some is like in the small intestine.
Right. That is also true. It depends on different types of enzyme. Some enzyme can work better in acidic condition, and some enzyme can work better in basic condition. But let's just talk about normal condition right now. So our body, it has normal conditions, and usually, if the normal condition is how can I say? If the conditions deviate from the normal, the enzymes will not be able to function normally anymore. So for for the temperature, we have the optimal temperature is 37 or 40 degrees Celsius, 37 to 40. And by the way, I think the meeting will end in 5 minutes. In that case, we will take a break and then you can join again. All right. So for pH, the optimal pH is 7. So what happens when the temperature is too low or too high? What happens if the pH is too low or too high? What happens is that, in those extreme conditions, the bonds in the enzymes will be broken, especially the hydrogen bonds. Just now I said that enzyme is a tertiary structure, right? And for the tertiary structure, we have the hydrogen bond, disulfide bonds, and so on. But especially when temperature is too high or too low, when pH is too high or too low, the bonds, especially hydrogen bonds in enzyme, will start breaking. And as a result, the 3D shade of the enzyme will lose its shade. And then what happened is that, the activity will no longer be normal. The enzyme will no longer be able to function normally. So the activity of the enzyme decline. So the rate of reaction also decline. So that's the temperature and pH. You can write the same concept for both temperature and pH. But then, for the enzyme of bacteria, which can survive in high temperature, maybe the optimal temperature for the bacteria is high. For example, this one. You need to know this graph. So this is the optimal temperature. And you can see that the rate of the reaction is the highest here. But as the temperature decreases, as the temperature increases, the rate of reaction goes down. You need to know this graph. The same goes for the pH. But what I want to show is here. This is for bacteria, hot spring bacteria, which can survive in high temperature. So for this type of bacteria, the optimal temperature is 70 degrees Celsius. So this is the highest rate of reaction here. But then it decreases. If the temperature decreases, the rate of reaction start decreasing. And the same goes for the high temperature. All right. And then pH, the graph for both pH and temperature are the same. You need to know this as well. The labeling, be careful of the labeling. You need to add it. If the question asks you to draw the graph, you have to draw it, and you also need to add the label. And then let's see the substrate concentration and the enzyme concentration. I will just go straight to it. So the concept about substrate and enzyme concentration is if we increase the substrate, the enzyme activity is also increased. So the rate of reaction is also increased. This is the rate of reaction. I just write it down for you. This is the rate of reaction will also increase. The same goes for enzyme. If the enzyme concentration increase, its activity will also increase. So as a result, the rate of reaction will also increase. But they have limitation. So let's just say that, we are increasing the substrate concentration. It will surely increase. The activity of enzyme will surely increase because most substrate will bind to the active site of enzyme. But then, we are not increasing the enzyme. So what happened when we are increasing the substrate only and not increasing the enzyme? What happened? What happened? Anyway. Is it got
enzyme will work a bit slower because the substrate keeps increasing and the enzyme remains constant. So the enzyme can't take a break.
Can't take a break. Well, it's not wrong, but it's not entirely true yet. So I will give you an example. So originally, this is the original. Let's say that, we have 3 enzymes. And then we have 1 substrate only. So this is a substrate, and this is enzyme. But now I want to increase the concentration of substrate. I want to increase the number of substrate. So I will add 2 more substrate here. So it becomes 3 substrate, right? And now 3 enzyme. I have 3 enzyme. 3 enzyme, 3 substrate. So 2 more substrate will bind to another 2 enzymes, and the rate of reaction will be increased here. So this rate of reaction is higher than this normal condition. Do you get it so fast? Because, I'm adding substrate concentration. The substrate concentration becomes 3, and more substrate concentration will bind to more enzymes, and the rate of reaction increase. But now I'm not increasing the number of enzymes. I'm going to increase the substrate concentration. I'm going to add more substrate concentration. Let's say that the substrate concentration is now 5. Now we have 5 substrate. In that case, what happened? We only have 3 enzymes, and now I have 5 substrate. What happened is that only 3 of the substrates will work together with this 3 enzyme, because we only have 3 enzymes, and 2 more substrate will need to wait for their turn to work together with enzyme. So for the substrate concentration, for the effect of substrate concentration on enzyme activity, what you can write is like, when the substrate concentration is increased, more substrate will bind to the active site of the enzyme, and enzyme activity will be increased as well. So the rate of reaction will be increased. But because we are not increasing the enzyme, we are not increasing the concentration of enzyme, what happened is that, all the enzyme will be filled with the substrate, and that extra substrate will have to wait for their turn to fill the active site. So at the end, what happened is that, the enzyme will work at its maximum point. You will reach this level. There is no more enzyme. This level shows that there's no more enzyme for substrate to bind with the enzyme. So here is what happens. The enzyme are working at its maximum level. That's why we call this maximum Vmax. That's why we call this Vmax. And then all the enzymes are filled with substrate. So the other substrates will have to wait for their turn. That is what happened at this stage. So, even if you increase the substrate concentration, it doesn't affect the rate of reaction anymore. This one is the key word. You need to know this one, what happened at this, as soon as it becomes this line, the straight line. What happened is this one and this one. You need to know that. You get it? Is there any questions? Is there any part that you don't understand?
No.
No.
Okay, then I will move to the enzyme concentration. The same goes for the enzyme concentration. If you increase the enzyme activity will be increased. And at the same time, let's say that you are increasing the enzyme, but you're not increasing the substrate. So the same goes with the enzyme, because you don't have enough substrate, the enzymes will be vacant. Like I said, let's say if you have 5 enzymes and 3 substrate only, so only 3 of the enzymes will work and 2 enzymes will not work because you only have 3 substrate. This will not work. Only 3 enzymes will work. Is it clear?
Yeah.
Okay, so if you want to, achieve the faster rate of reaction, what you need to do is you need to increase both the enzyme concentration and the substrate concentration. Once again, you need to know this graph and this one, the labeling. Try to understand that, all right? And then I will move to enzyme cofactors. What happened in the enzyme cofactors? Just last week, I think I told you that there are simple protein